The purpose of this lesson is for us to eventually be able to find cosine of pi on 3, for example, without having to use our calculator. If we want to find the exact value of a trig ratio, or the value of a trig ratio, we can do that by measuring on triangles. So if you measure these distances on your page, they should be something like this, all in centimeters. We can use this triangle to find sine, cos, and tan of 24 degrees. Okay, just using our normal ratio rules, sine of 24 is the opposite side divided by the hypotenuse, 2.7 divided by 6.8, which gives me something like 0.397, which is roughly the value of sine 24, verified on my calculator, 0.40. That's pretty close. A little bit of rounding due to my measurements, but that's the idea. I can do the same thing for cosine and for tan. Cos is adjacent over hypotenuse. It should give me 0.926, and tan is opposite over adjacent, which should give me 0.423. And you can check those with your calculator, that they're pretty much right. So that's where these trig ratios really come from. What we're going to look at are two special triangles which we're going to use to find sine, cos, and tan of these three angles, of pi on 6, pi on 4, and pi on 3. And the way we'll do this is being a little bit creative. So for the first triangle, I'll start with the square of side length 1. If I make a right angle triangle in here, I know that this angle in here is 45 degrees, but we don't talk in degrees anymore, we talk in radians. I can use Pythagoras to show that that side is root 2. Okay, and this is a triangle which I'm now going to memorize. So I'll put this in my little memorization cloud. I need to memorize this triangle. 1, 1, root 2, with pi on 4 as both of these angles. So what this allows me to do is now to find sine, cos, and tan of pi on 4. So sine of pi on 4, here's my pi on 4 here, opposite side divided by the adjacent side, 1 on root 2. You can do the same thing for cosine, adjacent over hypotenuse, again 1 on root 2. And finally for tan, opposite over adjacent is 1 on 1, which is just 1. Okay, so this black triangle is the one we used for finding sine, cos, and tan of pi on 4 radians. Another triangle I'll memorize is from this equilateral triangle. In this case, we'll start with an equilateral triangle where all the sides are 2. I know that this angle, since it's equilateral, is 60 degrees, but we don't use degrees anymore, we use radians. And I'm going to cut this in half. So this distance here is 1. I have a right angle. This angle up here is half of 60, so 30 degrees, which is really pi on 6. And you can use Pythagoras to show that this is root 3. So another triangle to memorize is this one. Pi on 3, pi on 6, 2, 1, root 3. And this is going to allow me to find sine, cos, and tan of pi on 3 and pi on 6. So I'll start with pi on 6. Sine is opposite over hypotenuse, so half. Cosine, adjacent over hypotenuse, so root 3 on 2. And tan is opposite over adjacent, so 1 on root 3. Okay, and then from the point of view of pi on 3, we can do the same thing. So sine will be root 3 on 2, cos will be a half, and tan will be root 3 on 1, which is really just root 3. Alright, so memorizing these two triangles lets us find sine, cos, or tan of any of these angles. In some textbooks, instead of having 1 on root 2, it'll have root 2 on 2. So which one is it? Well, if I have 1 on root 2 and I multiply it by root 2 on root 2, I'll end up with root 2 on root 2 times root 2, which is 2. Okay, so it's the same. Just for your recognition. So all of these ones where it's 1 on root 2, we could actually write as root 2 on 2 as well. You can use either form of these that you prefer. And in a similar way, this one that's 1 on root 3, some people like to write as root 3 on 3. Okay, you just need to be able to get a value. Okay, so you need to be able to, if someone says, what is cos of pi on 3? You need to be able to draw this triangle and get a half as your answer. A little application of this, just so we can see how this could possibly be used. So if I wanted to find the exact height of the tree in the diagram below, exact height sort of implies don't use your calculator, it should just be fractions and exact values. So I'd identify that this is the opposite and this is the adjacent. So I'd be using tan, write my rule, substitute in the values that I know. Okay, and now I could obviously isolate h, so multiply both sides by 105. So this is something that I would normally type into the calculator with my calculator in radians, but I could notice that that's pi on 6, draw my triangle, and identify that this would be 105 times tan of pi on 6, so opposite over adjacent from the point of view of this pi on 6, times 1 on root 3. So the height of the tree would be 105 on root 3. Let's just assume we're talking about meters. And that gives me the exact value without needing to use a calculator. Okay, so from here, have a go at practicing finding these exact values. I think there's some in degrees, some in radians. But remember, all you need to do is memorize these two triangles and you're on your way.